Hello everyone, I am Pankaj Singh welcoming all of you on this Drishti online platform for the 100 most important topics for Prelims 2026 section, and in the 9th episode, and I think you must be enjoying all this episode, and if you have any kind of doubt please ask. And now I am going to, I say that start with the 8th episode questions, and then going to give answers. If you have any kind of doubt related to that answer, what is your job, go back and see the 8th episode. Okay, so here these are the topics we have covered in the last 8th episode, and here let us see this question that consider the following statement regarding the temperature variation in the atmosphere. Temperature decreases with height in the troposphere. Yes, this statement we can say that it is a right statement. Temperature decreases with height in the troposphere because of, I say that decrease in the water gaseous or air density over there, and then adiabatic expansion. But again, if you want to listen all these things, what I said that explanation of it, why it is happening, all are explained in the what 8th episode. So here I will give you the answer only, so that you can correctify yourself whether it's right or wrong, whatever you last 8th episode. So another, the temperature increases with height in the stratosphere due to the presence of ozone. Yes, this statement is also correct, because you know that already ozone gases are able to absorb UVB and UV rays, and the temperature is started keep on increasing height. And temperature increases with height in the mesosphere. No, in the mesosphere I said that the density of the gases are very less, keep on decreasing, therefore the temperature decreases. So only we can say that option A 1 and 2 only is correct. Now here consider the following statement regarding the ozone layer. The maximum concentration of ozone is found between 20 to 30 kilometer altitude. Yes, within the stratosphere at this altitude you can say that ozone is existing high concentration. The second statement is talking about the ozone layer absorbs ultraviolet B and ultraviolet C radiation from the sun. Yes, it absorbs that they are very harmful, and that is absorbed by the ozone layer. This statement is also correct. The ozone layer is primarily responsible for reflecting infrared radiation back to the earth. No, it is only absorbing UVB is and all. So it is not infrared radiation back to reflect back. This statement is what wrong. If you have any doubt, go back and see the video of what 8th episode, so you can be able to understand. Now which of the following statement given is are correct? You can say that option A 1 and 2 only is correct. Now consider the following statement regarding ozone depletion. So there is what chlorofluorocarbons and halogens contribute to the depletion of ozone layer. Yes, it is contributing in the what depletion of ozone layer, but if it has said only, then it can be wrong, because there is a nitrous oxide, different gases are there also, so many ozone depleting substances gases are. But here if it has been said that yes, it is causing chlorofluorocarbons and halogens contribute to the depletion of ozone, yes, causing. And then ozone depletion is most prominently observed over the Antarctica region. Yes, that is known as also Antarctica hole, ozone hole over the Antarctica. During spring season it occurs, and now it has been revived at a very good level. So here we can say that second statement is also right. Ozone depletion leads to increase in ultraviolet radiation to reach the earth's surface. If the ozone hole is there, then the UVB, UVC rays will be easily able to come onto the earth's surface. So this statement is also correct, and we can say that the option D 1, 2 and 3 are what correct. Another, consider the following statement regarding ionosphere. The ionosphere is a part of thermosphere and contains ionized particle. Yes, this is the right one. If you have any kind of, again I am saying that every time, if you have any kind of what I said that why this answer is correct, go back and see the last video and the last episodes. In this one it has been made very clear that why it is so. The ionization in this region primarily caused by solar radiation. Yes, this statement is also right one. And then the ionosphere reflects radio waves helping long distance communication. So it helps radio waves and the long distance communication is also taking place. This statement is also correct. So we can say that option D 1, 2 and 3 all are correct here. And the next one, consider the following statement regarding global temperature records. The global temperature refers to the average surface temperature of the earth. The first statement, global temperature refers to the average surface temperature of the earth. Yes, this statement is what right. NASA and NOAA, NASA National Aeronautic Space Agency, and the National Ocean and Atmospheric what you can say that administration are among the agency that monitor publish global temperature data. Yes, there is also World Meteorological Organization is also there. So these two are there. Yes, this is correct one. And global temperature is measured only over the land surface, exclude ocean. No, by the ocean bios. There is an, I said that several datas of the ocean we are also, land also, everywhere the temperature record is maintained. So this statement is wrong. It is saying only over the land surface. This is wrong one. Is okay. So we can be able to say that option A, 1 and 2 only is correct. Now consider the following statements. Global average temperature has increased by 1.1 to 1.3 degrees Celsius above pre-industrial level. That's a correct statement. Above pre-industrial level, that temperature has increased by 1.1 to 1.3 degrees Celsius. Go and see in the last videos, it is available. And second statement is talking about that pre-industrial temperature baseline refers to the period after 1950. No, it is after 1850. So this is what you can say that 1850. After 1850, so on the basis of that, it is written 1950. It is wrong. July 2023 was recorded as the hottest month globally. Yes, this statement is right. And 1 and 3, you can be able to see option C. 1 and 3 only is what correct. Now that next it is greenhouse gases like consider the following statement. Greenhouse gases like carbon dioxide and methane contribute to global warming by trapping heat in the atmosphere. So greenhouse gases like carbon dioxide and methane contribute to the global warming by trapping the heat in the atmosphere. Yes, it is enough. There are so many other gases are there, but it is also correct one. And the deforestation reduces carbon absorption. Yes, so deforestation, it is done by the human activity. It reduces carbon absorption, thereby contributing to rising temperature. This is also right one. Ice albedo feedback is a negative feedback mechanism that reduces warming. No, it increases warming, and it is in a positive, not negative feedback mechanism. It is in a what? Positive feedback. So where you can be able to say that this statement is what? Wrong. And here option A, 1 and 2 only is correct. After that, we can say consider the following statements. El Nino year are generally associated with the higher global temperature. Yes, because the El Nino year is itself associated with the high temperature. So therefore, when it will be high temperature, it will be try to what is increase the global temperature also. So this statement is what correct. Arctic amplification refers to the faster warming in polar regions compared to the rest of the world. Yes, there is a 2 to 3 times yes in the what temperature, and then faster, I said that melting of ice, that is in a what in comparison to the rest of the world, it is 2 to 3 times faster. You can see that 2 to 3 times faster. 2x to what I said that 3x. And then melting of polar ice contributes to sea level rise. That's a very easy one. Yes, it is melting of polar ice contributes to the sea level rise. So we can be able to say that all the statements are correct regarding that. Now, yes, with reference to the Earth's atmosphere, which one of the following statement is correct? The total amount of insolation received at the equator is roughly about 10 times of that received at the poles. This is the wrong one, because you know that no one has said that how much. You cannot determine that it is 10 times more than the poles. So it is never has been mentioned anywhere. It is so. So this is the wrong one. And another one, I said that infrared rays constitutes roughly 2/3 of the insolation. I have discussed about that in the earlier episodes, said that is when the sun rays which are coming out of that 42 to 43% is what visible rays, it is visible, and then 43 to 54% it is what infrared rays, and then 3 to 8% it is in rays. So that infrared rays are around 50%, you can say, but it is talking about 2/3 of the insolation. So therefore it is in a what wrong. Infrared waves are largely absorbed by the water vapor. Yes, water vapor which is that returning back, there is a greenhouse gases are there, and there is a water vapor that is what absorbing, that is concentrated in the water lower atmosphere. So this is what I said, that water vapor which is responsible for the what absorbing more. So this statement C is what correct, and then automatically we left with this D option is wrong. Infrared waves are the part of the visible spectrum. No, infrared VIBGYOR is the part of visible rays are the part of visible spectrum. Yes, and a VIBGYOR. Infrared is not there. So infrared has a frequency less than rate of visible rays. So we have seen this option C is correct. Now we are going to see that in this episode of the 9th episode, in this one, that we are going to see the tricellular model, Hadley cell, Ferrel cell, polar cell, and then intertropical convergence zone, what is there, and seasonal shift of ITCZ we have to see, and then ITCZ and its what I said, that impact on the Indian monsoon. So here what we have to see, the tricellular model. You know that in the Earth's atmosphere, due to the rotation of the Earth, and Coriolis force, we have 3 cells are there, tricellular model, which help in what I said, that help in distributing temperature and then maintaining what temperature, a high temperature in the equatorial region and tropical region to the polar region. The heat is transferred through the atmospheric circulation, and there is 3 cells are there. One, you can say that 0 to 30 degree, Hadley cell is there. 0 to 30 degree Hadley cell is there. It is in a kind of what this way Hadley cell, and in this region the Hadley cell descend down in this region, and because of that you can say there is a what subtropical high pressure, and this region has a desert region. You can say that in this it is happening Hadley cell. Similarly in the southern hemisphere, whatever it is happening in the northern hemisphere, similar in the southern hemisphere also. And here the second one is in a Ferrel cell. You can say that it is in a what 30 to 60 degree latitude, it lies between one, and here you can say that westerlies, here it is a northeast trade wind. In the Hadley cell there is a northeast trade wind and southeast trade winds are moving, but in the Ferrel cell you can say that here it is a wind which are moving in the upper atmosphere, and the lower atmosphere it is in a westerlies are there, 30 degree to 60 degree, and thereafter we can be able to say that it is in a polar cells. You can say that Ferrel cell and the polar cell. In the polar cell, here the winds are moving up and down. Here it is like that, it is coming in this direction, and it is coming in this direction. It is coming in this you can say that direction. When it is coming in this direction, you can be able to say that it is in the form of polar easterly. So here we can be able to say that there is in a polar easterly. So there are 3 Hadley cell, 0 to 30 degree, there is in a Ferrel cell 30 degree to 60 degree, and then polar cell it is 60 degree to 90 degree, and these are the 3 things are there. So here we can be able to say, but in this region one more thing is there, because of the heating, this Hadley cell which is coming because of the thermal direct, thermally originated, is in a thermally originated. This is thermally originated, and then our this polar cell is also, you can be able to say that thermally originated, thermally directly originated, and because of these two it is in a indirect one it is there. So it is in a thermally direct, it is thermally direct, because of that you can say so it is a thermally direct Hadley cell, and polar cell thermally direct, but it is in a indirectly, there is no, because of the it is known as the dynamism also. So here we can say that consider the following statement regarding the tricellular model of the atmospheric circulation. The Hadley cell operates between equator and 30 degree latitude. Yes, this is we have to say whether it is in a right or wrong. Another, the Ferrel cell lies between 30 degree and 60 degree latitude, and it is in thermally direct circulation it is talking about. Ferrel cell, the middle one, it is in a thermally direct. You have to see whether it is right or wrong. You have to give your answer, and I am waiting in the I am waiting for your comments in the comment box. So here Hadley cell, it is in a tropical cell. Here before getting into this, and a Hadley cell, it is in a tropical cell. Here you can say that from the subtropical high pressure to the equatorial low pressure, this is you can say that it is in a, you can say that northeast is in a, you can say that there is in a here this is in a northeast trade wind is there. It is a northeast trade wind, and the southern hemisphere is a southeast trade wind. It is on the surface from the subtropical high pressure to equatorial low pressure, subtropical high pressure to equatorial. Here the warm air is rising up. Here the warm air is rising, convecting upward and creating a cumulonimbus cloud, and it is creating a high pressure gradient with respect to the poles, and there is also temperature. Because of that, the winds started moving faster towards the poles, but by reaching 25 to 35 degree or 20 to 30 degree, it become heavy enough and started descending down. So in the upper atmosphere it is moving, in the lower atmosphere it is moving from the what you can say that is to, you can say that it is moving from the what east to west, but in the upper atmosphere west to east it is moving. And this is in a kind of what in this region where it is descending down this Hadley cell, it is making this region a very dry hot, and that becomes converted into desert. You can say it is a 20 to 30 degree also, it can be what 30 degree also only, you can say like this, and 25 to 35 degree also in both the hemisphere. Here the northeast trade wind and the southeast trade wind, on the surface it is moving, and when it is rising up it is moving west to east and then coming down. So this is the what Hadley cell, it is in a very much important part of it. And in this region what you can be able to say like here Hadley cell, here the equator to 30 degree, it is talking about, yes, where it is extended, equator to 30 degree, strong heating at equator and air rises, that I have shown you, and it creates a low pressure ITCZ on the ground. So here you can be able to say there is a low pressure, it creates a low pressure, and when the air moves up on the ground, the amount of air reduces, it becomes a low pressure, and it is also known as what you can say that it is an ITCZ. It is also what we can say that it is an ITCZ, low pressure you can say. And here we can be able to see that it creates low pressure on this ITCZ. Air moves poleward at the upper level of the atmosphere. Yes, in the upper level of the atmosphere, here the yes, air is moving towards the poleward. Here the air is moving towards the what poleward you can say, and here, and then it cools and sinks at 30 degree and creates subtropical high when it cools, and what I said that 30 degree, and it is creating a high pressure, subtropical high pressure. And then you know that the surface winds, trade winds are there, northeast trade wind in northern hemisphere, it is coming from the northeast direction, southeast trade wind southern hemisphere it is there. What is the impact? Equator is getting heavy rainfall. Here equator is getting in a what you can say that heavy rainfall, and there is in a desert formation at the 30 degree. So here you can be able to say there is a desert formation, and that 30 degree deserts will be there like Sahara, Arabian, several deserts are there. For this is about Hadley cell you can say. Now there is a northeast trade wind, and this is in a southeast trade winds are there. This northeast trade wind, and it is in a what southeast trade wind. So consider the following statement regarding Hadley cell. The trade winds originate from the subtropical high pressure belts, coming from subtropical high pressure belt and blow towards the equatorial low pressure region. Yes, equatorial low pressure and then subtropical high pressure region. So whether it is right or wrong, you have to see. Air rises near the equator due to the intense heating. In the equator, it is due to intense heating rising and creates a low pressure zone. Yes, we have to see whether it is right or wrong. The Hadley cell is responsible for the formation of major desert regions around 30 degree latitude. So you have to see whether this what I said that the statements are right or wrong, and how many of them. So please answer your option, and I will see your comments in the what comment box. And here that we are going to see, it is about what Ferrel cell, and Ferrel cell already it is in a kind of what between 30 to 60 degree, and here it is you can say that here it was in a, here you can be able to say there is a Hadley cell is going on, but in the Ferrel cell it is in a Ferrel cell is there, it is from the subtropical high pressure to what subpolar low pressure it is moving, subtropical high pressure to subpolar low pressure, and here this it is creating in a kind of what you can say that front and temperate cyclone formation. Here it is in some kind of front formation and temperate cyclone formation, because there is a cold wind is coming from the polar region, and thereafter the warm air rising upward, creating in a cloud, causing heavy rainfall you can say, and then here it goes and complete in a what so this is in a westerlies, it is known as in a westerlies on the ground. Here in the same way southern hemisphere is the same way, and it is in a from 30 to 60 degree you can say on an average, but it is this way you can be able to also stand. So here it is I am talking about in this region there is you can say that westerlies in the southern hemisphere also, it is moving from the west to east, it is in a westerlies are there from subtropical high pressure to what subpolar low. In this region the front is forming, and because of the front temperate cyclone formation also come into existence. Yes, in the coming episodes it will be also explained, but here it is only I am talking about this Ferrel cell. So here we can say like now what it is this Ferrel Cell which we have seen, it is coming into the effect because of the what? Thermally indirect, not this is an equatorial region, high heated region, there is a thermally direct. This polar region is very cold, it is in a thermally direct, but it is formed in between, it is in a thermally indirect one, must remember that. So here that extent Ferrel Cell, if I am talking about, it is in a mid latitude cell also, it is lying 30 to 60 degree, indirect cell, not thermally driven, must understand, not thermally driven, and air flows poleward at the surface and equatorward in the upper atmosphere. So here, yes, you can be able to say that the poleward in the water, it is in a poleward in the surface, the air is this wind is which is moving poleward in the lower surface, and in the upper atmosphere towards equator, it is what here again was the what poleward in the lower surface, this westerlies, and then in the upper atmosphere it is moving towards the equator ward. So in the Ferrel Cell, here it is air flows poleward at what the surface and equator ward in the upper surface, and it is in a westerlies, and you can see that it is in a west to east in both the hemisphere. And here where it is the front formation, it is helping, and temperate weather means that front formation, temperate cyclone is associated with the what I said, that front formation. And when you understand about the temperate cyclone formation, that is known as an extratropical cyclone, it is also known as it has been given by Turkani's brother. Its name, you can say it is the name of this theory for the explaining this temperate cyclone is known as a polar front theory. So polar, it is associated with the front, it is okay. So here we have been able to see, and now this is in a westerlies are there from the west to east, it is moving like that. Now you have to say that consider the following statement regarding Ferrel Cell. The Ferrel Cell extends from 30 degree to 60 degree latitude in both the hemispheres. So you have to say whether it is right or wrong. Second statement, it is a thermally direct circulation. It is in a thermally direct. We have to whether it is say that for it is in a thermally direct or not. So that idea you have to circulation driven by intense heating at the surface. And the third statement, surface winds associated with this cell are westerlies blowing from west to east. So these three statements are there. Accordingly, you give your answer. The next one that we have to see, polar cell. Before doing this one, let us see. It is in the polar region. You can say that our winds are moving, like I said, that polar high pressure to the subpolar low pressure, and it is moving like this, and then means it is moving equatorward on the surface, and then it is in a known as an itself easterlies. It is in a polar easterlies itself. I will show you. And in the upper atmosphere, and it is rising up in the form of front formation. Again, listen me, this region has in a front formation, temperate cyclone. Yes, and already Ferrel Cell part and this polar cell part, this is creating in a what, this is the cold air mass, this is in a warm air mass coming, and in this region, and it is on the surface moving equatorward, and the upper atmosphere towards the poleward. The same here it is in the southern hemisphere, it will be there. It is from the 60 to 90 degree latitude, you can be able to say extension, and it is in a polar cell. So here and here the dry winds are here, the cold and dry winds descend in this region, and that region is very dry, the polar region is becoming very dry. And here, so its extension, you can say that 60 degree to 90 degree working, cold dense air sinks at poles, there is a sinking down, and it is creating high pressure. When the air is descending now, when the air anywhere descend down, it is creating a high pressure. Here you can say that it is in a what air is descending down in this region. In this region, air is descending down, so create a high pressure itself. Is it okay? So and cold dense air sinks at poles and create high pressure, moves towards 60 degree, rises with the front or temperate cyclone formation. So here it is moving towards 60 degree. Here it is moving toward this one, and they are together making an what front formation. It is a easterlies or polar easterlies coming from this direction, east to west formation of what temperate cyclone, you can be able to see. And here the same thing, here the same whatever you are watching here in this region, the same polar easterlies is this. And we can say that what polar easterlies, the name of the wind is polar easterlies, or you can say only easterlies. You can also say only easterlies, it is also correct. Here it is in a what, in the cold and dry polar region, the air which is, I said, the descending cold, there is no moisture, there is a dry region. Temperate cyclonic rainfall in the subpolar region, that it is in a subpolar region, you can say that in this region temperate cyclonic rainfall and the front formation, you can also say happening. So this way you have seen. And then consider the following statement, that air moves from the poles towards 60-degree latitude. Air in this region, air moves from the poles towards 60-degree latitude at the surface in the polar cell. Whether it is right or wrong, you have to see. Air moves from the pole towards 60-degree latitude at the surface in the polar cell. Second, rising air around 60-degree latitude is associated with the tropical cyclone, or what it is, you have to say. This is right or wrong. And then polar cell is characterized by cold and humid climatic condition. Cold or humid, or cold or dry, whatever it is there, you have to check it out. So accordingly, you have to answer this question based on the polar cell. Next one, we can be able to say that ITCZ. ITCZ on the, what we can say that this is the region where the winds are. This is your northeast trade wind, and it is in a southeast trade wind which are converging. So it is in a converging within the tropic. Therefore, it is known as an ITCZ, intertropical convergence zone. Within the tropic, the air are converging, and it is in a low pressure zone where the warm air started rising up. This is the area where the warm air, and this ITCZ, when the sun shifts in the northern hemisphere, this ITCZ or low pressure zone also shifts in the northern hemisphere. When the sun comes over there at equator, it is also over there, and when the sun shifts in the southern hemisphere, it also shifts along with the sun in the southward also. Here you can be able to say that itself it is an ITCZ. You can say that the northeast trade wind and southeast trade winds are converging, and then same thing, it is part of Hadley Cell, you can say. And here you can say that it is in the northeast trade wind, and then there is what southeast trade winds are converging, and thereafter it is known as an ITCZ. And in this region, heavy rainfall, that low pressure and the water vapor goes up in the upper atmosphere, this cloud forms, and there is a heavy rainfall takes place and thunderstorm and then doldrum condition. ITCZ is in a region where the pressure is wind does not move everywhere low. So low pressure, if it is there, you can be able to say that wind does not move from the low to low, it moves from the high to low. So this in a doldrum means calm condition, it is there also. So here, and in this region, air is rising up, already we have shown you. So what it is, I said that intertropical convergence, ITCZ. It is a zone where trade winds converges. Means northeast trade wind, you can say that there is a northeast trade wind, and then what southeast trade wind converges near equator. Low pressure belts, it is an equatorial low pressure belt, it is there, and then here in this region air is rising upward. And in this region, what is happening? Heavy rainfall is taking place when the air is upward moving in the what equatorial low pressure zone or ITCZ. It moves upward and causing, I said that cloud formation, especially cumulus and cumulonimbus cloud. In this region, every day rainfall occurs. 12 to 2 p.m. there is a cloud formation, and then 2 p.m. to what I can say that 4 p.m. rainfall must occur, and in the form of thunderstorms, lightning, and what we can say that this ITCZ is belongs to the doldrum region. So I think you are able to understand this thing. Yes, and here we can say that here you can say again it is an ITCZ, rising air, low pressure, all these things are there. Northeast trade wind and southeast trade wind is converging, therefore it is in what intertropical convergence. So here consider the following statement regarding intertropical convergence zone. It is a low pressure belt located near equator. Whether it is right or wrong, you have to answer it. It is formed due to the convergence of trade wind from both hemisphere. Yes, you have to say whether it is right or wrong. The ITCZ is associated with the heavy rainfall and thunderstorm. So we have to see all this statement, and then properly I said that take your time and give the answer. It will be very nice questions are there, and then it will the concept, if it is clear, the answering these questions will be very easy. Please, I am waiting for your comments in the comment box, and keep on associating with us, and then try to what I said that if you like our videos and then these episodes related to the UPSC and Prelims 2026 that we have targeted. So if you like it, I said that subscribe this channel and then go ahead with that. So here we have been able to see that this question. Now the next one, I said that seasonal shift of ITCZ. Very important here it is, I said that yes, when the sun shifts into the northern hemisphere, when the sun shifts into, you know that if I am talking about you know that this is your it is your what I said that equator 0 degree, and then this is your Tropic of Cancer 23.5 degree north, and this is in what I said that 23.5 degree south. So speak some number with me. 21st, what I said that 21st, 22nd, 21st March, 21st June, what I said that 21st March, 21st June, 22nd September, 22nd December, 3 months gap. So here you can be able to see, like I said, that on 21st, you can say that on 21st March, sun is over the equator, and after that it moves northward, and 21st June it is able to reach what? Tropic of Cancer, and after that 21st June, you can say that it start moving towards equator. By reaching 22nd September, it is reaches near what equator, and from there 22nd September that it moves into southern hemisphere. After that, in the 22nd December, you can say reaching to the Tropic of Capricorn, and thereafter again from the 22nd December, you can say that again start moving northward for the 21st March at equator. So this is a kind of what from 21st March onward, the June till what 22nd September, it is northern hemisphere. The sun will also be in northern hemisphere. When the sun is in northern hemisphere, that ITCZ also shifts along with that. When the sun goes into the southern hemisphere, then the sun goes in the southern hemisphere, heating is also going more, and then the heating of the what land, water and all, it moves into the what I said that southward. So we can be able to say, because of this reason here, we can say like that why does ITCZ shift? It is an apparent movement of the sun. Sun is apparently shifting in the northern hemisphere, and it is in the northern hemisphere for 6 months, and apparently shifting in the southern. It is not exactly. It is due to the what tilting of the earth with 23.5 degree with respect to vertical, and then revolution around the earth. It is in a major factors which is causing, I said that the sun sometimes it looks in the northern hemisphere, in the sometimes southern hemisphere. Yes or not? For 6 months northern and 6 months southern hemisphere. So it is an apparent movement. So there is not exact movement, apparent movement of the sun, or after apparent shifting of the sun, and also differential heating of the land and ocean. Ocean and the land, it is also helping, I said that, creating a low pressure and ITCZ accordingly. When the sun moves northern hemisphere, the land and what I said that ocean will also be heating, and then it creates an what ITCZ and low pressure. So differential heating of the land and ocean, it is also the yes there is never a same heating. Land is what is heated fast in the summer, and the water body low, because of the land specific it is very low, 4 times low than the water. Here in the summer northern hemisphere, we can say that ITCZ shifts northward up to the Tropic of Cancer, and in India it is a very hot. India becomes very hot, and then it is reaches to the 25 degree north. The Tropic of Cancer is 23.5 degree north, but it is able to reach in India more than that 25 degree north. So and then another one is strong heating over land. That is also important in the northern hemisphere, because India the land become very hot. In the winter, that is when the India in the winter, that time sun is in the southern hemisphere, and in our northern hemisphere winter is there, that time sun is in southern hemisphere. So when the sun is southern hemisphere, northern hemisphere will have a winter, sun is coming slant. So during that period, ITCZ will shift in the southern hemisphere. So we can be able to say that ITCZ shifts southward into the southern hemisphere that time. I think you are able to understand this one. So here in then ITCZ, it is an apparent movement. ITCZ is in the northern hemisphere sometimes. Yes, when it is the sun is in northern hemisphere, or ITCZ shifts in the southern hemisphere when it is in a what sun is in the southern hemisphere. So here we can be able to say that these are, consider the following statement regarding the seasonal shift of ITCZ. I am talking about seasonal shift of ITCZ. Yes, it shifts in the north and south, you must be knowing. The ITCZ shifts northward during the northern hemisphere summer due to the apparent movement of the sun. Second statement, differential heating between land and ocean do not influence the position of the ITCZ, that it is there, whether you have to say right or wrong. The ITCZ remains fixed near the equator throughout the year due to the contrast constant solar radiation. So did I discuss these things? If you have to check it out whether it is right or wrong according to the what explanation that I have given. Is it okay? So here now ITCZ, and we are going to see that Indian monsoon, the role of ITCZ, and here if I am talking about, yes, ITCZ when it is shifting in the northern hemisphere, you know that when the ITCZ, it is shifting in the northern hemisphere, ITCZ shifting is there. So ITCZ means what? Intertropical Convergence Zone, and due to this Intertropical Convergence Zone, here you can say that there is a southeast trade winds are there, and this southeast trade winds, which are moving in this direction, they crosses equator to come to what? ITCZ. They wants to come to this ITCZ, and then they become and deflected rightward. In northern hemisphere, because of Podis force, the southeast trade wind wants to come this ITCZ region. They wants to come to this ITCZ region, and again I said that when it wants to come to this ITCZ region, what will happen? This southeast trade wind with high pressure waiting in the Indian Ocean, southern Indian Ocean, they will cross the equator and then deflect rightward and looks like coming from southwest, and it is known as a southwest monsoon, and that India receives because of that ITCZ shifting in northern hemisphere, India receives what? Monsoonal rainfall, and this region you can be able to say that this region is in a monsoon trough, low pressure create over there, monsoon trough is there. Is it okay? This way we can be able to say that this is the reason. Here we can say that now ITCZ in Indian summer, in the summer time ITCZ you can say that shifts north over the India, creates monsoon trough. Trough means low pressure because of the heating. You know that the ITCZ is based on the differential heating of land and water body. So ocean differential and the land, it is more heated. So there is on the land it is more shifting. Ocean is less heated, land is more heating. So ITCZ shift more into the on the land. It creates monsoon trough means low pressure, and if it is a low pressure, it draws moisture laden winds from the oceans, and then moisture laden winds come towards the ocean, and from the ocean to the land, it leads to the southwest monsoon rainfall, and then southeast trade wind crosses equator, deflect rightward. Deflect, what happened? Yes, tell me. Rightward, and it creates a southwest monsoon. So here we have been able to see that southeast trade wind crosses equator, wants to come to this ITCZ. What is the meaning of ITCZ? Intertropical Convergence Zone. If it is an intertropical convergence zone, the wind will come to the what? This ITCZ region, and try to what I said that by reaching southeast trade wind, crosses equator, deflect rightward, becomes southwest monsoon. So here we can be able to say that consider the following statement regarding ITCZ in the Indian monsoon. During the summer, the ITCZ shifts northward over the Indian subcontinent, forming a monsoon trough. We have to say trough means low pressure. So you must understand whether it is right or wrong. The monsoon trough helps in drawing moisture laden wind from the surrounding oceans. You have to say whether it is right or wrong. The ITCZ shifts southward during the summer, and the ITCZ shifts southward during summer, leading the onset of southwest monsoon. So which one is correct or wrong? We have to see accordingly. Is it okay? So we have been able to see that this ninth episode, these topics we have been able to finish, and even if you have any kind of doubt, please give your comments, and if you have any doubt related to that, any question if you are having, go back and see all the episodes. It will help you immensely in your preparation of UPSC Prelims 2026. So we will meet in the next 10th episode. Till then.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.